Hey, this is Mack and this is Lab 5 called Why Do My Knees Hurt? Um, so the purpose of this lab is to calculate how much force I put through my knees when falling during bouldering. A short preview that ends up being roughly 369 pounds of force, and we only need a few physical principles to calculate this, really. Um, so the first thing we need is, most importantly, a net force equation or a free body diagram to get it. And the only two forces we have here are the contact force and the force due to gravity. Um, the force due to gravity we use is actually the simpler version, which is just mass times the gravitational acceleration. And then we do need to know Newton's second law and the definition of the acceleration principle um, for the calculations that follow. So what I did was I dropped from the top of the wall with my feet being approximately 2 meters off the ground. Let that happen here. And both my knees bending and the cushioning of the mat increase the time I have to slow my motion to a stop. This means that I don't have to put as much force in as quickly, because you can imagine if I came to a stop immediately. Well, if I came to a stop immediately, that'd be an infinite amount of its force. Except, I guess I don't even know how I would calculate that, to be honest. But yeah, so you want to increase the time to stop, which is why there's mad and why I bend my knees. So according to tracker, I reached a maximum of negative 5.745 meters per second in a 0.6 second time frame when falling. So this would be right before I hit the ground. This is close to what we would expect. I think I calculated this and got something in the range of 9.5, 9.6 meters per second squared, which is, yeah, pretty close. I then slowed to a stop in 0.4 seconds. And for this calculation, we're going to assume that that force is equal throughout the motion. It probably wouldn't be, but for our purposes, it's going to be close enough. So first of all, we're going to find out our acceleration during that time frame. Acceleration is just equal to the change in velocity over time, which we calculate here to be 14.36 meters per second squared. With acceleration, we can get our net force if we simply multiply by my mass, which is 68 kilograms. And this gives us 976.65 newtons as our net force. However, we don't just have contact force here. We have the force due to gravity pulling us in the opposite direction. So we need to actually add F net and F grav to find out my contact force against the ground. We calculate the force due to gravity as you would expect, mass times the gravitational acceleration, and simply add the two to get my contact force, which is 1,643 newtons. 369 pounds is a lot, but you end up hitting this at the bottom fully stretched, and yeah, I mean, it's why they tell you not to drop. It's why they tell you to roll back and not drop directly on your knees. It is bad for you. So here are my graphs. So there is a lot of error. The position graph looks very nice, but the velocity graph doesn't, which is sort of to be expected because velocity obviously is a derivative, so the errors will be more apparent. So first of all, one of the main things that makes it unreliable is I'm pinpointing my center of mass, which is obviously extremely inaccurate. More than that, the camera angle is not perfect. I think the guy filmed it in 0.5. That makes it not as accurate. And there's a lot of things here that are estimated because, despite the fact that I know how tall I am and I measured my arm length, ligaments stretch when you're hanging off the top of the wall. I don't think my legs were hanging all the way down. It's hard to get extremely accurate, but we're just trying to get roughly what I'm putting on my body during this fall. And we've learned enough to get accurate guesses of that information, which it's really cool to calculate all these things that they give us problems in and tests very accurately, but a more valuable skill to just use in our day-to-day life is just to roughly guess what we're putting our bodies through. And I have learned enough to be able to do that, which is really, really cool. Thanks, guys.